Okay, doing a couple problems from the quiz review. I'm going to start with 4. So you have to get the root out of the bottom. So in order to do that, you need this many 2's total. So you've got 1 2, you need 5 2's total, which means you need 4 more 2's. So you're going to multiply the top and the bottom by the 5th root of 2 to the 4th. So on the top, you've got to do 3 times 2 to the 4th, which is 16. So then you're looking at the 5th root of 16, x to the 7th, y to the 12th over, not 16, 16 times 3, so 48 over 2. So then you need to break the top down. So you'll put 48 in your box and break it down. So you've got 2, 24, 2, 12, 2, 6, 2, 3, 3, 1. So in order to take anything out, you need 5 of them. You have 5 of nothing, so it doesn't break down. So then you're looking at the 5th root, and the 48 will stay in. X to the 7th, if you have 7 x's, that's 1 set of 5 with 2 left over. If you have 12 y's, that's 2 sets of 5 with 2 left over, and it's over 2. If you don't have a fraction, then the way that you break it down is just the way that I was breaking the top part down. So like for 2 and 3, it's just like the top part, okay? Exponent rules, which is your next section. There's quite a few different things. Just trying to see which one I want to look at. Okay, we can talk about, I'm going to go with 6. Okay, when you have exponents inside and outside a set of parentheses, what you do is you distribute and then you multiply. So you've got 2x to the negative 8th, and here you've got x to the 15th and y cubed. And then when they're on the same level like this, what you do is you add them. So then you have 2x to the 7th and y to the 3rd. If you had any of them be negative, you would then just move them to the bottom, is how that would work. 23. Oh, I'll do 12 and then 23. All right, so same thing. You're going to distribute your outside powers. So then you're looking at x to the negative 12th and y to the 21st and z cubed and 2 squared and x to the 4th and y to the negative 2nd and z squared. So then you want to add all the individual ones together. So you want to figure out what 2 squared is, which is 4. So we'll do that. And then here you've got x to the negative 12th and x to the 4th, which is x to the negative 8th. Y to the 21st and y to the negative 2nd, which is y to the 19th. You've got z cubed and z squared, which is z to the 5th. And then this is negative, so it pulls down, but nothing else does. So those use the majority of your exponent rules, other than the division ones. But I was going to talk about a division one next. So I'm going to talk about, now I'll do 23. So the fact that you have an entire fraction that's negative, that's bad. You never want to distribute a negative power. It makes everything weird. So what I always like to do is I flip the entire fraction over, changing none of your signs, but then it'll make this a positive 4. And that's easier to distribute. So then you want to distribute the 4 within here. So then you've got x to the 12th. And really, once you've distributed the 4, you want to look at the entire top and the entire bottom separately and then simplify the whole thing. So then this would be x to the negative 4th. Then here you've got x to the 8th and y cubed and y to the 4th. So putting stuff together, you've got 12 and negative 4, so you'd add them, so you have x to the 8th over x to the 8th and y to the 7th. And then when they're on the top and the bottom like that, you can subtract them. Or you can just sit there and go, if I have 8 x's on the top and 8 on the bottom, how many would I have left? And you would have none of them left. So then you have nothing left in terms of x's, and all you have is a y to the 7th on the bottom. So since nothing's on the top, you put a 1 as a placeholder, and the y to the 7th stays on the bottom. So your next simplifying section sort of combines, I guess, exponent rules and the simplifying stuff. So looking at, trying to look for ones that do stuff, say 28. If you've got x to the 8/3 times x to the 5/3, first thing you do is you use your exponent rules and you would add them together. So 8/3 and 5/3, you're looking at x to the 13/3. So then you want to shift it from looking like this to putting it into radical form. If you remember, when you put it into radical form, the top one is the power on x, and then this is the number that goes in here. And then it's like the very first thing that you did. You sit there and go, okay, I've got 13 x's. I can pull out sets of 3. So if you have 13 x's, that's going to be 4 sets of 3 with 1 left. Numbers work pretty much the same way. So like if you look at 32, here you are dividing basically, so you want to subtract your exponents. You have 9/4 minus 1/4, which is going to be 8/4, which is 2, and then you just figure out 4 squared, which is 16. And then the last section was all of the operations with square roots, which you should have notes on.